Two of the following videos are true while the other one is trash. Can you spot the fake? Season 2, Episode 8. Round 1, let's begin. First up, grab a sheet of paper and write something on it. Then place it into a Ziploc bag and seal it. Then draw something on the outside of the bag in Sharpie. When you place the bag into the water, you can see that the words written on the paper will disappear when viewing from this angle, but the stars drawn on the outside of the bag do not disappear. If you take a beaker of water, weigh it on a scale, and then carefully dip your finger in the water, you'll see that the reading on the scale does not change because your hand is holding up the weight of your finger, meaning there's no additional force transferred to the scale. If you blow bubbles, they'll pop almost immediately when they touch your hand. However, if you wear cotton gloves, you don't need to make any modifications to the bubble soap, and the bubbles won't pop nearly as easily, and you can bounce the bubbles repeatedly. You've seen all three videos now. Pause to vote in the comments which one you thought was fake. Wearing cotton gloves does help prevent bubbles from popping. If you thought this video was fake, well, you'd be wrong. From this angle, the words on the paper do seem to disappear. This is due to the way light refracts through the plastic bag and the water. If you look at it from a different angle, you can see that the words are clearly still there. That means this video is fake. The reading on the scale does rise when you dip your finger in the water. Your finger is displacing water, and the buoyant force acting on your finger acts equal and opposite on the water and therefore the scale. I simply masked the reading on the scale to make it look like it didn't change. Here's a quick recap to help you follow before moving on to the next round. Hopefully you got that right, but if not, it's time for round 2, a prediction round. If you take a piece of graphite pencil lead and place it across the terminals of a 9-volt battery, you can touch a match to the graphite and the match will light. If you drop food dye into a glass of water, the food dye slowly sinks and mixes with the water like this. However, if you place a bunch of sugar in the water and stir it up to dissolve it, now when you drop food dye into the glass, the food dye will rise back to the surface and not immediately mix like before. If you place two inflated balloons of slightly different size on both ends of a PVC valve, when you open the valve, air will flow from the larger balloon to the smaller balloon until there's the same amount of air in each. You've seen all three videos now. Pause to vote in the comments which one you thought was fake. When the graphite shorts the 9-volt battery, the graphite gets hot enough that it can ignite the match. When dropped into denser sugar water, the food dye does rise back to the surface instead of mixing right away. Here's a view when dropping the food dye from even higher, and it's pretty cool to see. That means this video is fake. The air actually goes from the smaller balloon to the larger balloon when the valve is open. That's because the pressure does not simply rise as the balloon is inflated, but rather looks something like this. So in this example, the smaller balloon is actually at a higher pressure, and since air flows from higher pressure to lower pressure, when the valve is opened, air flows from the smaller balloon to the larger balloon until both pressures are the same. This is also the correct explanation for why the smaller balloon beat the larger balloon in a race during a previous episode of Two Truths and Trash. The smaller balloon, being at a higher pressure, produced more thrust. I actually missed this part of the explanation in that video, which didn't affect the answer for that round, just the explanation, but I wanted to correct that here. Sorry about that. Anyway, if you take a large inflated balloon and an empty balloon and do the same thing, what's going to happen? Pause to think about it based off this graph. Since the larger balloon is at a higher pressure, air will flow to the deflated balloon until that balloon has the same pressure. And as you can see, the deflated balloon barely even inflates before the pressures are already the same. This whole concept might seem surprising, but it makes sense once you remember how blowing into a balloon is most difficult at the beginning. Here's a quick recap to help you follow before moving on to the next round. Now it's time for the final round, round 3. If you take a straw that has been cut to this size and place it between two glasses, one empty and one full, the water from the full glass is siphoned to the empty glass until the water level is equal for both. These nails are not magnets, but if you take a strong magnet and place a nail on it, you can string together multiple nails without them falling. Next up, take a Brita and place it next to the sink. You'll notice the faucet nozzle doesn't stay up, and you might think I need to sit there and hold the faucet as I fill it up. However, if I turn the faucet on, the thrust from the water shooting out provides enough force to keep the nozzle up. Then when I'm done, I turn off the water and the nozzle automatically falls back into place. You've seen all three videos now. Pause to vote in the comments which one you thought was fake. If you thought this video was fake, you'd be wrong. You totally can chain multiple nails together using a magnet. Also, turning on the water does allow me to fill up my Brita without me having to hold the nozzle. This is the second interesting phenomenon that I've observed with the sinks in my apartment, and it was simply too interesting for me to not include. Anyway, if you thought this video was fake, well then you'd be right. This is not a real way to siphon water, and nothing happens if you place this between the two glasses. You have to dip the straw upside down underwater to fill up the straw, and then quickly but carefully turn the straw over. When the water on the right side of the straw starts to fall, it's not just going to leave a vacuum behind, but rather the negative pressure instantly pulls the water from the left side along with it. And this flow continues until the straw is either no longer submerged in water or the water levels are the same. That's how a real siphon works, but to make it look like it worked, I did some careful masking, and being that I'm not a great editor, I was pretty happy with the result. Shout out to Definite Articles for submitting the idea to chain nails together with the magnet. Thanks for watching to the end, and I'll see you in Season 3.